No, go ahead.
Hi everyone. Can you hear me back there? Yeah. I'm Shin Young from Team Raspberry Farm. Remember my name, please. And today I'm going to talk about our project, infrared detector. So before starting, this is the contents. First, I will quickly look over our topic again, and then I will discuss about what we have studied so far and what we have done so far, and then future tasks. So let me explain about our topic in a nutshell. So there are farms in this world and even more animals and some bad guys. And as you experienced yesterday, the weather here in Indiana is not really good. And it is hard to see the intruders during the night. So our goal is to detect intruders using infrared cameras so that we can keep detecting the intruders even during night and even in bad weather and alarming to farmers. And if we have some enough time, we will make a system that sends an email to farmers using LoRa. So this is what we have done so far, but it is too much, So what I want to say here is the main thing is that we started studying the basic concept of machine learning, and it took some time because we started from scratch, and we tried implementing some pre-trained model like ResNet 50, YOLO version 3, and YOLO version 3 Tiny, and we've been customizing that pre-trained model to make the model fit for our project. So I want to talk about what we have studied so far to do this our project. So the basic question is, what is machine learning? It is all about changing parameters of function. So this is neuron. It is the basic unit of neural network. It takes one input and it makes one result. So a lot of neurons make a group, and it is like a one big function box. And let's say it's a deer detector, and once you put an input image, it calculates whether it is deer or not, and then it makes a result. This process is called forwarding. And because it is deer detector and it is deer image, it should say 1, because it is deer. But we got only 0.8, so there is some loss here. And by using these laws, we will adjust these parameters, and this process is called backpropagation. And backpropagation helps this model to have some optimal parameters to do our task. And the next question is, what is CNN? CNN stands for convolutional neural network, and convolutional means that it is the multiplication of matrices. And each matrices represents some specific feature of the input image. Like, for example, let's say we put a deer image, and then one matrix can be like represent horns, and other can represent eyes, nose, and so on. Yeah, and why should we use CNN? You see this tiny little picture? I drew it on my laptop. And can you guess what size of this picture is? It is 100 by 100. It means that its input size is 10,000 pixels. So it means that this tiny little picture, to process this tiny little picture, we have 10,000 neurons just in the first layer, and even more other parameters. So it means that the model will be really heavy and slow. So like you see, this is really tiny. Then what it would be like if you put an image like you've taken with your iPhone or Galaxy, it must be really huge. But CNN reduces the dimension while extracting the important features. So that's why we use CNN. And we chose YOLO model for our project. YOLO is one of the most state-of-art model in object detection area. And YOLO stands for You Only Look Once. It is speedy, works well, so it fits for our real-time system. So how YOLO works? First, it divides the input image to grid cells, and it puts each grid cells to this convolutional network. And this convnet is the function box here. And it keeps putting the cells, no dear, no dear, no dear, yes dear. And because not only one grid cell expects a dear image, it could get some multiple results like this. So it is not wrong because there is deer in this red box, and there is deer in this purple box, and that box too. But because there is only one deer here, we want only one result. So by using non-max subtraction, YOLO will choose one bounding box with the highest value. Ta-da. Yeah, so that was it. And now I want to talk about transfer learning. Transfer learning is transfer learning. So it's like you make a detector that detects person, laptop, bag like that, and then you reuse this model to detect like earphone, bottle, and so on. So this kind of transfer learning makes the whole progress much, much faster. And we use this kind of pre-trained model. So that was for me, and I'd like to hand over to Sonia now.
We did some experiments on our laptop. We used pre-trained model of YOLO version 3 and YOLO version 3 Tiny. Let's see the result of YOLO version 3. As you can see, YOLO version 3 can detect a lot of objects like person, laptop, cup, TV monitor, and so on. However, its speed was too slow to use for our project. Next, let's see the result of YOLO version 3 Tiny. It detected less objects than original YOLO version 3, but it was much faster. We have some trade-off between speed and accuracy, and in our project, frame per second is more important than accuracy, so we decided to use YOLO version 3 Tiny in our project. YOLO we used earlier is based on COCO dataset. COCO dataset is large-scale object detection, segmentation, and captioning dataset. It includes 80 kinds of objects like human, dog, cat, giraffe, car, truck, bus, and so on. Our project goal is detecting deers in orchard, but unfortunately, deer is not included in COCO dataset. So we need to customize we need to some more additional work to detect custom objects like deer. First, we trained our model using snowman images in Google Open Images. It worked well with this kind of snowman images. Next, we trained our model using deer images. As you can see, the performance of our model gets better as the training iteration proceeds. Finally, we tested our RGB trained model with deer images taken with infrared camera. We trained this model only using RGB deer images, but it worked pretty well. So I'm pretty sure that we can improve our model if we use grayscale or infrared images of deer in the future.
So now I'm gonna talk all about setups we've done, such as hardware installation or making environment to run our program on Raspberry Pi. So first of all, these are hardware we mainly use. The IoT device should be in the middle of farm, so we need small, low power computing device such as Raspberry Pi is currently famous. And as I said, we need thermal camera. But there are some conditions. It should be possible to be connected with Raspberry Pi like this. It should be possible to send the data in real time. So this one is what we choose. It's called Lepton. We choose it because it's quite developer-friendly product. There are several modules are provided, and the one I wanna emphasize is from PyLepton. This is Python library, and this is compatible with OpenCV, which is image processing library, so that we can analyze real-time raw video data from the Lepton modules. And the Raspberry Pi should be possible to run our program, so there are several things we have to consider: operating system and what kind of language we are using, and some libraries for that. So these kind of things must be installed on Raspberry Pi, and we've done that. And finally, these things are what we are going to do in the rest of time. If possible, we are going to build a wireless system so that we can notice the farmer that's subdivided in your farm. And we will add more hardware components to improve our performance. And about object detection, because we are dealing with thermal images, the amount of data must be the problem. So what we are trying to do is just to make colored image grayscale and train model with them. We are not still sure that it works or not, but it doesn't work. We have to gather thermal images by ourselves. Thanks for listening. Any questions?
So what kind of detection time are you looking at? I'm sorry if you had that in there, maybe I missed it. So a deer walks in front of the camera, how long is it gonna take before you can notify the farmer, or what's the reaction time, I guess is a good way of putting it?
We didn't think about that, but
Actually, we need to